Hi, so today I'm going to be explaining what an inductor is and what its purposes can be in a circuit. There are many different purposes to an inductor that I'm not going to be covering today. I'm only going to be covering the absolute basics and the things that are kind of interesting if you are looking to do laptop or cell phone motherboard repair. And let's get to it. You can think of an inductor, for the most lack of a better explanation, this is really a crude explanation, as the opposite of a capacitor. So a capacitor, as I explained in the past video, can pass AC because it's two plates with an insulator in between, but it cannot pass DC because the DC will simply hit the plate and fall down because there's an insulator in front of it. Now, an inductor will pass DC, but it does not pass AC very well. The higher the frequency the AC is, the worse the inductor is at passing it. And also, one of the things about an inductor is that it resists quick changes in current. So you should watch the voltage versus current video if that's a little confusing to you, but an inductor will resist very quick changes in current. And that's something that we use against the inductor to get it to do what we want. Again, what I want you to think about when you're thinking about electronics and circuits and what the things do, think of it like manipulation. We are manipulating these electrons, we are manipulating these particles, we're manipulating these materials to get it to do what we want. It's not, just stop thinking of it like math and equations and all that stuff. Think of it just like at a fundamental level, just think of it like manipulation in a bad relationship. And if you do that, and you just think of it like manipulation in a bad relationship, it actually starts to make sense. So, one of the great uses of an inductor, since it can resist current, is in a DC to DC boost circuit. Now, I haven't explained exactly how a DC to DC boost circuit works. I may do that in a new video. But I feel like having an inductor video without explaining the DC to DC boost circuit would be a great injustice. So let me just shrink this so that you can see what's on the screen so I can show you one of the great practical uses of an inductor. Now, as I said, an inductor is going to resist changes in current. And one of the things that you can do to trick it into giving you more voltage for any given input voltage is short the one side of the inductor to ground over and over again. So let me give you an idea when that would come in handy. So this over here is going to be a backlight circuit in a MacBook Pro. Let me just show you that over here. All right, so this entire machine runs off of 12.6 volts, right? It runs off of a standard 12.6 volts. And the backlight, it needs a minimum of around 25 volts to actually start turning on. So the backlight in the machine is running off of somewhere between 25 and 39 volts, depending on your screen. So what are you going to do? You could send that thing all the amperage in the world. It's not going to turn on if it doesn't see a voltage of 25 to 39. That's what the LED strip inside the thing works off of. So here's what we do. We're going to trick the inductor into giving us a higher voltage. Again, the system is only able, it can put out a lot of amperage at 12 volts, but it's only going to be able to put out 12.6 volts. How do we trick it? Again, we don't need a lot of current. Think about it. Even at 30 volts, even 1 amp through that circuit would mean that we have the capability to deliver 30 watts of power. We don't need 30 watts or 40 watts or 50 watts to power a screen. We need like a couple, if even that, to power this tiny little laptop screen. So we want to convert our low voltage, high amperage supply into a high voltage, low amperage supply. Now, let's look at the screen over here and get an idea how this is done. So on the left over here, you're going to see that this is 12.6 volts on input. And we need to get to 30, 40, 50 volts on output. So this is a little inductor. Now, how is this inductor going to actually make the voltage higher? What, do you just put an inductor there and ask it to? No, we have to manipulate the electricity, the same as I explained in the other video. So in the video about ground, I told you that electricity, it just fundamentally hates existing. Think of electricity like stress. Electricity is stress in your workday, stress in your life, stuff that you, and it doesn't like being there. The electricity, the molecules, they would like to be sitting at home doing nothing. They'd like to be sitting home on their couch relaxing. They don't want to be stressed out. And what I did as a demonstration is with my power supply, what I did is I showed you what happens when you touch the 20 volt part to the ground. You see that spark? You hear that? Yeah, that's no good. That's going to put my eyes out. The point is, whoa, okay, I'm eventually going to blow this thing up. But the electricity is so desperate to go to ground. It will spark, it will scream, it will light fires, it will go through you. It will do whatever it needs to do to get to ground with all of its energy, and it is not going to care. It's going to run as fast as it can towards that ground because the electricity wants to be at equilibrium. It wants to be at 0 volt. It doesn't want to be charged. It feels pain and stress and misery being charged. You know, again, think about the poor little electrons. Think about the poor little electrons that you are torturing so that you can watch this YouTube video, so that you can have lights in your apartment. It's mean, it's cruel, it's sad, and we do it on a regular basis, and nobody thinks about those poor electrons. So, back to the inductor over here. Now, remember that the inductor resists change in current. We didn't say anything about voltage. The inductor resists change in current. Don't ask me how it does that. That's something that I should have went to college for and not got 50s throughout every test I took in math in high school. Now, see this? What we're going to do is we're going to trick it. So this is the 12-volt rail. This is the inductor. After the inductor over here, it goes to this backlight chip. And ignore all this fuck shit over here, this VDDIO, villain, backlight iSense, filter, FSET, SCL. Just fuck all that shit for now. Think of it very simply like this. This over here where it says SW, which is going to right after the inductor, that's called switch. And what that's going to do is that's going to switch this inductor to ground. So instead of it just going to its standard nice little load over here, every now and then instead of going to our standard nice average medium load, we're going to skullfuck this inductor and send all of this electricity directly to ground, which is going to make the electricity go vroom, just like it did over there. You're going to see the spark, the pop, all that's happening in real time. And we're going to do it really fast. Now, again, but the problem here is that inductor, it's not allowing the current, the amperage, to go through as it would like it to. So that 12.6 volts, it's not going to be able to send 3 or 4 or 5 or infinite amperage through. It's not going to have the capability to do that because the inductor is keeping the current there. But it just got shorted to ground, so something has to go through this thing. What do you think is going to go through it if it can't send more current? More voltage. The way I want you to think about this is like so. Think of that backlight chip that's switching you to ground, like the driver hitting the brakes, and think of the inductor like the seatbelt. So you're moving at your regular pace, but as soon as the driver stops short and the inductor is keeping you in the seat, just like the seatbelt, you're going to go like this really fast. So instead of you moving at your standard little 20 miles an hour, for that split second, for that very short fraction of a second, you're moving at 40 or 50 or 60 or 70 miles an hour or whatever it is when you decide to jump and you move that fast. And imagine doing that over and over again. Can you imagine just how much torture that would be to a live human being? Well, that's what you're doing to your electricity every single second that you are watching this video with the light in the screen. You're torturing it. You're manipulating it. You're being mean to it. And that's how this works. So what happens over here is you're going to get all of that power stored up. It's not going to be 12 volts. It's going to turn to 15, 18, 21, 24, 27. And the frequency at which you're stopping short, this is stopping the electricity and sending it to ground, is going to determine the actual voltage that you get. So that's one of the ways that we use an inductor to manipulate a circuit to get what we want. So what I'm going to do right now is I'm going to zoom in on the oscilloscope so that you can get a good visual representation of what's going on in the circuit, because I really want you to understand this by actually seeing it. And this is one of the great things I love about the oscilloscope. Again, a lot of people say you don't need an oscilloscope, especially if you're just getting into these circuits. And the thing is, you're right, you don't often need it, but it's a great learning tool, because when you can actually visualize and see what it is that's going on inside the circuit, it helps you in creating that explanation inside of your head. And again, as I explained, I'm fully self-taught with everything that I know how to do right now. I had mentors that taught me certain things when I was a teenager, but really what they taught me was how to think. And that was what helped me going forward, and that's what got me where I am. So right over here, I'm going to be showing you what's before the inductor, again, the 12 volts going in, and I wanted you to see what happens after the inductor. So the first thing that I'm going to measure here is going to be on pin 1, which is before the first pin of the inductor where it starts. So let me just measure that on here. Now remember, that's going to be the 12.6 volts that's going into my inductor. So that looks like this, and this is on a computer that's powered on with the screen working. So it's measuring 13 volts. That could be because the system is not running as it's supposed to, because this is a liquid damaged board. It could be because this is the cheapest oscilloscope that I could find that's being held up by a container of flux and a speaker. Or whatever, who cares? But the point is, you get it. At the beginning of the inductor, you get the regular 12 volts. Now watch what's going to happen on the other side of the inductor where it's being switched to ground all the time. So I'm going to touch the inductor probe over there. Look at that. So look, it's a bunch of spikes. It goes to ground and goes back, goes to ground, goes back, goes to ground, and it's 0 and then going back up, 0 and going back up. So one of the things that you should notice here on VTOP is it says VTOP is 26 volts. Now we have all those spikes, and it says the average voltage the thing is reading, the average voltage it thinks it's getting there is 17 or 18, and the top of it is 26. Now let's see what happens in the rest of the circuit. Let's see what it looks like. So let's see what it looks like on the input of the diode and on the other side of the diode. So we're going to look on pin 1 of the diode and pin 2 of the diode and see what it looks like there. Because again, even though I'm just talking about inductors, this is kind of cool stuff if you're literally realizing it for the first time, how it works. And I want you to be able to really get a picture of how this works and really understand it, and even if we haven't finished our basic lesson plan yet. Because one of the things I used to hate about regular school is right as you're actually getting into the interesting part, right as you're getting into where you're actually learning something and understanding, and it's no, fuck you, time for regents, time for citywide test prep and other bullshit. It just takes away the fun out of everything, and I can't stand that. So we're going to look on pin 1 of the diode now. And again, that's the same thing. And after the diode, where you have those smoothing capacitors, it's going to look like this. It's just a smooth, straight up 27.4 volts. Cool, right? And that's one of the cool things that an inductor does. I can also show you that on the CPU V-core circuit. So let's go over there and show you what that looks like. So firstly, that's different than a DC to DC boost circuit. So a DC to DC boost circuit is meant to take a low DC voltage and turn it into a higher DC voltage, right? Now this inductor over here, again, remember, this was where the flat voltage was coming in. And on the other side of the inductor, on the end of the inductor, that's where we were having the spikes come out. And then those spikes were getting smoothed by these capacitors over here. Now we're going to visit a different type of circuit, where this is for CPU V-core, and I want to show you how that works. That's called a buck regulator. I'm going to have my own video for a buck regulator, because that's a whole nother topic altogether. I probably should include it in this one, but I don't want to cram too much into a video that's supposed to be just about the inductor. But this is one of the other uses of it. Okay, so over here what we're trying to do is take a high voltage and turn it into a low voltage, right? So before we were taking a low voltage and turning it into a high voltage. Before we were taking the low 12 volts, and on the other side of the inductor you were seeing the switching, and that was turning it into a higher voltage. Here we're actually trying to do the opposite. What we're doing is these two transistors are going to be pulsing this energy down here into a bunch of little pulses, and through this we want to have a lower voltage. Now remember, the inductor can only pass DC. It does not pass AC well, particularly high frequencies of AC. It doesn't do that well at all. And the capacitor over here is only passing AC. So think of ground here, like I said in the other video. It's like where we send electricity to die. Think of it like our electricity garbage pail. So what this is doing is it's sending any type of AC to ground, whereas it's allowing the DC, only the DC to pass through the circuit. The capacitor, which we've explained how it smooths DC voltage. Remember, the powers really want to get to the other side, but the DC can't get to the other side, so it gets slammed against one end of the capacitor, so that keeps the line flat. Whereas the inductor itself is not good at passing AC. It's not good at passing rippling high frequency. It's terrible at it. It passes DC. So what we're going to do over here is we're going to take that ridiculous rippling and pulsing, and we're going to turn it into something a little bit more usable. And I want to show you that on the screen. Again, all of this stuff, like on how buck converters work and how inductors limit and all that, it's all confusing and it's all worthless when you don't actually get to see it. Seeing is understanding, seeing is believing, and I wish they had more of that in school. You have no idea how much I wish I had more of that in school. So here is going to be the input of that inductor that we saw. And it spikes, so you can get a little better idea. Let me just turn this thing up there. All right, see that? It's a bunch of spikes. It's a bunch of pulses. Pulsing, pulsing, pulsing. So see how V top is 12 volts? Remember, the computer's power supply runs off at 12 volts. So what it's doing is it's taking that 12 volts and it's just limiting it. It's saying, okay, you can have 12 volts now you're not. And see what it's doing is it's opening that 12 volts and it's closing it. So it's constantly opening and closing it, opening and closing it. So it's not boosting the 12 volts at all. All it's doing is giving you 12 volts and then closing. So over here, let's get a pointing stick here. So see, you got 12 volts and then we're closed. And now we have 12 volts here, and now you don't have 12 volts anymore. Then you have 12 volts and then you don't have it anymore. So it's constantly turning it on and off. And the whole idea here is it's kind of like averaging, right? So it's averaging, what we're doing is we're trying to average 12. So let me just get that back on there. My finger slipped. So look, we got 12, and then 0, 0, 0, 0, 0, 0, 12, 0, 0, 0, 0, 0, 0, 12. And when you average 12 with all those zeros, eventually you get to a point where you're mathematically at 1 volt, right? That's the way the circuit works. We're going to average out 12 and 0, 12 and 0, 12 and 0, or for example, 12 plus 0 divided by 2, that comes out to 6, right? 12 plus 0 divided by 3 is going to come out to 4. 12 plus 0 plus 0 plus 0 divided by 4 is going to come out to 3, and so on and so forth. So it's kind of like taking the mean, the average of this and the other numbers, which is 0. Now let's see what happens on the other side of this, where we have on the other side of the inductor that also has the capacitors going to ground. You get something, it's not perfect, don't get me wrong, because again, we're taking a bunch of pulses and trying to turn it into something on a laptop motherboard, but it's not going to be perfectly smooth, but you get, it's pretty damn smooth. That looks nice. Yeah, it's not the smoothest thing in the world, but it's close enough. It's better than that pulsing shit that we were looking at before, right? Because that pulsing shit from before was worthless. Like this, at least you can power a CPU off of. So, long story short, inductors assist us in manipulating electricity by giving us just another tool, another way to do it, another set of little restrictions that we can put on electricity. Because when we have places that we can send electricity, and then we have different ways of restricting how we send that electricity, it allows us to come up with new and cool ways to create circuits that do what it is you want using the limitations of what is available out there in the world. And this is another thing that an inductor can do. This is another application of an inductor. That's what the inductor looks like on the schematic over there. So just to make sure, since I didn't actually ever show you what the inductor is, it is this little thing that's squiggling, not to be confused with the resistor. So the resistor is this spiked squiggling thing, whereas the inductor is the more, it looks kind of more like fingers on a hand squiggling thing over there. And that's about that. The next video we're going to be doing is going to be on transistors. We're going to be doing a couple of more videos on components, and then we're going to be going into the things that components can actually do, and then we're going to go a little bit more into schematic reading and troubleshooting and all of that later. But first, we do have to get through what these basic components are and what these basic components do. I'm trying to make the explanations as basic and as simple as possible because, again, my target audience is somebody who's going to start reading a basic electronics book, go, oh my dear God, and put it back in the drawer for another 2 or 5 years because it's so confusing. I'm not talking about farads and henrys and substrates and germanium and silicone and how they interact and coulombs and any of that crap. That again, that is very, very, very important if you want to be an engineer. That's incredibly important if you want to be an engineer. But I'm not trying to turn you into an engineer. I'm trying to turn you into somebody who can follow what I'm talking about in these basic videos. And if I get that done, I'll be very happy.